This is example 2 on rational functions day 2. So the first thing that we want to do whenever we are going to graph any rational functions is to fully factor the numerator and the denominator. So we can see that the denominator is already fully factored. So next we're going to look to factor the numerator. So I always give myself a little workspace. I have x cubed plus 3x squared minus 6x minus 8. So a trick for this is frequently we're looking to see if we have a common factor between the numerator and the denominator. So one of the things that I might do is go in and see using long division if x minus 2 is a factor. Okay, so right now pause the video and do the long division. After completing the long division, I can see that my numerator is going to factor into x minus 2 times x squared plus 5x plus 4. But then I notice that x squared plus 5x plus 4 is going to factor into x plus 4 times x plus 1. So I can rewrite my entire numerator as x minus 2 times x plus 4 times x plus 1 over x minus 2. So now at this point, you do not need to do these things in the order that they appear in our list. Okay, we're looking for vertical asymptote, horizontal asymptote, slant asymptote, x-intercepts, y-intercepts, and holes. So the first thing that I always look for is to see if there's anything I can divide out. And if I can divide something out, that's the x value that corresponds to that factor is going to be where my hole is. So looking at this, I can see that x minus 2 is going to divide out. Because the factor of x minus 2 divides out, the x that corresponds to that factor that would make this equal to 0 is 2. So for my hole, I'm going to know that my x coordinate is 2. Now, to evaluate the y value for my hole, I want to look at my reduced function. So my reduced function is going to be f of x equals x plus 4, x plus 1. So now what I want to do is I want to evaluate at the x value for my hole. Now see, the problem, if I try to evaluate out of my original function, as soon as I put in the 2 minus 2, I would have gotten undefined. Okay, so I can't find that y value. So that's why I use my reduced function. So when I find f of 2, this is going to be 2 plus 4 times 2 plus 1. So this is 6 times 3, which gives me 18. So my hole is going to occur at 2, 18. So now I'm going to look at what's next in my list. I have a vertical asymptote. Do I have a non-canceled factor in the denominator? Since I don't, I do not have a vertical asymptote. For my horizontal asymptote, I want to compare the degree of the numerator to the degree of the denominator. So again, some work down here for my horizontal asymptote. Right, the degree of my numerator is 3. The degree of my denominator is 1. So since the degree in my numerator is bigger than my degree in my denominator, I am not going to have a horizontal asymptote. The next thing that I have to check for is for my slant asymptote. So a slant asymptote only occurs if the degree in the numerator is 1 more than the degree in the denominator. So we already talked about this. The degree in the numerator is 3. The degree in the denominator is 1. Since those are not 1 apart, we also have no slant asymptote, so we write none. For my x-intercepts, I need to take the numerator of my reduced function and set that equal to 0. Using the zero product property, I have x equals -4 or x equals -1. So I want to write those as points. So my x value is -4. For my x-intercept, my y value would always be 0. And my other x-intercept occurs when x is -1. Again, the y value for x-intercepts is always 0. The next thing that we want to find is our y-intercept. So for our y-intercept, we want to find f of 0. It's easiest to use, you can decide which function that you want to use anywhere. For me, looking at this, if all of these terms, right, if x was 0, those would go to 0. This x would go to 0. So we would have -8 over -2, which is 4. If you plugged in to your reduced function, so f of 0 equals 0 plus 4 times 0 plus 1. Oops, sorry about that. So if you put into your reduced function, 0 plus 4 equals 0 plus 1, you would also get 4. Okay, you do not have to do both of these. Same with all of this work. If you can do it as mental math, just looking at your factored equation up here or your factored function up here, you do not have to write all of this out. However, I cannot give you partial credit if I'm not seeing your thought process. Okay, so we just found that our y-intercept was 0, 4. So I am thinking about this for a second. My new reduced function, because my denominator is 1, this is now actually a quadratic. Okay, so I have x plus 4 times x plus 5. The x times the x gives me x squared. Okay, we can actually see this down here. This simplifies to the equation x squared plus 5x plus 4. So since it's a quadratic, we know that the general shape of this graph is going to be a parabola. But what's different about this, what makes it a rational function, is it's going to have a hole. Okay, so looking at this, I see that I need my y values to go all the way up to 18. I also am going to pause for a second and make myself a table with some of x and y values. So I already see that I have -4, and I see that I have -1, and I have 0. Okay, I know those are 0, 0. At 0, I'm at 4. At 2, I'm at 18. Okay, so this is 3 from here. I'm going to go 3 in the other direction. So -7. So I'm just going to pause right now. Actually, I can probably do that pretty quickly. So if I want to find f of -7, I think putting it into my reduced form, so -7 plus 4 and -7 plus 1, that gives me -3 times -6, so that would be 18. So looking at this, I know that I need to get my y scale up to 18. It looks like I'll be able to see sort of the up and down of the parabola from my table. So I'm going to go up here. I'm going to keep my x scale as 10 to negative 10, but I'm going to change my y scale up to 20 and negative 20. So at negative 7, I'm up at 18. At negative 4, I'm at 0. At negative 1, I'm at 0. At 2, I'm at 18. At 0, I'm at 4. This is wrong because I need a scale of 2. Sorry about that. I was wondering why it looked off. Okay, so now I can use symmetry, right? So here are my two x-intercepts. My vertex is going to be right between that. So I want to look at